Okay, so this will go in section 4.3, and it's called polynomial functions. And Newton's method. And optimization. Okay, first, Newton's method is used to approximate Newton's method is used to approximate the zeros of a function. So when they're talking zeros, they're talking where does it cross the x-axis. Okay, and I'm going to take you through the process of how you develop and get the formula for Newton's method. Okay, so first, if we had a graph, and say I have a graph, I'm just going to show you part of it. Say I have a graph that looks like this. Okay, when you look at your calculator, the very first thing you do is you're going to make a guess, okay, as to where it crosses the x-axis, okay? And your guess is actually not going to be the exact answer, so it's going to be off a little bit. On this one, okay, if I say choose my first guess, so on this one, you're going to graph your polynomial, your f of x, and guess a first approximation of a root or 0. Okay, the first one I'm choosing, okay, it's going to be close to where it crosses, but it's not going to be exact. So if I said my first guess was this x value, x sub 1, okay, then this y value is f of x sub 1. Okay, so we basically choose our x sub 1, and that gives us a y sub 1. Okay, if you go back in the formula for slope m, and we said m was the same thing as our first derivative. F prime of x is the first derivative. It is the slope of the tangent line. And remember, that's the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? Now, here's what happens. We're going to figure the slope of the tangent line. Okay? When you figure the slope of the tangent line, it's going to cross the x-axis in another point, and it's going to then go back up to the curve. Okay? So then on this one, the point where it crosses, okay, this point, we're going to label that R0. Okay? The y value would be 0. Okay? So R0 is the point where the tangent line crosses the x-axis. Okay. Now, we basically have two ordered pairs. We've got this ordered pair, and we've got this ordered pair, and we can figure the slope. Okay. So, fourth step, f prime of x equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if I label these ordered pairs, I'm going to label this one is my x sub 2 y sub 2, and I'm going to label this one my x sub 1, y sub 1. So now if I fill into that formula, my y sub 2 is 0, my y sub 1 is f of x sub 1, okay, and my x sub 2 is r, and my x sub 1 is just x sub 1. Okay? So if I simplify the top part, that 0 drops out. It's just negative f of x sub 1 over r minus x sub 1. And that is equal to the first derivative. Okay? Now what we're trying to figure is, where does it cross the x-axis? Okay? If you cross multiply, let me write this again. If you take f prime of x and set that equal to a negative f of x sub 1 over r minus x sub 1, think of this as over 1. If you cross multiply, okay, you're going to end up with f prime of x equals times the quantity r minus x sub 1. So I'm just cross multiplying, and it equals a negative f of x sub 1. And I'm trying to solve for where it crosses the x-axis, so I'm trying to solve for r. Okay? So to get r by itself, okay, I can divide by the f prime of x on both sides. Okay, and then I'm down to r minus x sub 1 equals a negative f of x sub 1 over f prime of x. Okay. Now add x to both sides. When you add x to both sides, you're going to get r equals x sub 1 minus f of x sub 1 divided by f prime of x sub 1. Okay? So now, in the calculator, you're going to put in y sub 1, you're going to put in your original, just like we've done before. In y sub 2, you're going to do like we've done before, the numerical derivative of y sub 1 comma x comma x. Okay? And that is, here's the original, so that's y sub 1. Here's the derivative, that's y sub 2. So the formula becomes the root equals x sub 1 minus y sub 1 divided by y sub 2. Okay? And then you're going to press enter several times until all the decimals are alike. So here's what happens on the graph. The first time, you're going to guess x sub 1. You're going to figure the derivative. When you press enter, okay, you're going to get this root. Okay, then the calculator is going to take it up to this. You're going to do the slope of the tangent line. It's going to figure this one next. And then it's going to go up to the, and back. It's zooming in on this point right here. Okay, every time you press enter, you're zooming in on that point. Okay. Okay, so now let's look at an example. They will say use Newton's method, and we're going to add that formula to your card here in a minute. Use Newton's method to find the zeros. Now, when you're going through the homework, it may cross in more than one point. Okay, so then you have to make sure you're zooming in on the right zero, or more than one answer. You're going to get more than one. Use Newton's method to find the zeros of. Okay, here's the first equation. X cubed plus 3x plus 1 equals 0. Okay, so first, let's graph that. So put in x cubed plus 3x plus 1, and I'm going to give you a window on this one. The x window I want to be -4 to 4, and scale 1. And let's just go negative 10 to 10. Let's see how that does. And scale 1, let's see. And graph it. Yep. Okay. We could even zoom in on that a little bit more, but I just want you to guess. Okay. Like guess to the nearest tenth. Okay. Now, so you guess something other than me. Okay. I'm going to guess. My guess is going to be negative 0.3. So you guess negative 0.4 or negative 0.2 or guess something. Okay. Okay, now what you do is you take that guess, negative 0.3, and store that as x. Remember, that is the STO key on the calculator. So do negative 0.3, and whatever your guess is, store that as x, and use the xt theta n key, and you got to make sure you press enter. Okay, press enter for that to register. Okay. Now, in y sub 2, you still have to put in the numerical derivative. So you got to do math 8, the numerical derivative, and then use your vars key. Right arrow over to y variables, function, pick up y sub 1, comma, x, comma, x. Store keys down here on the... Which part? Put the original in y sub 1, okay, and then the numerical derivative of it in y sub 2. Numerical derivative of y sub 1, comma. Yep. Okay. Okay, so now we need to do this formula several times. Okay? Okay? So go to the home screen. Okay? Put in x minus. Okay, and then parentheses. Y sub 1, so we got to do the vars key. Right over to y variables. Function, pick up y sub 1, divided by, and then do the vars key again. Right arrow over to y variables. Function, go down and pick up y sub 2. Okay? Okay, now, my first guess was negative 0.3. Okay? Press enter. Okay? It went from negative 0.3. We figured the slope of the tangent line, it went down to negative 0.322. Okay, press enter again. It's going up to the graph, down the tangent line, okay, until you get all of them. Mine did it on the first one. Did you guys? Oh, hey, hang on a minute. No, negative 0.3, store that as x. Did you guys get the same answer? Is this? Yeah? Everybody got the same answer no matter what you stored? No. What'd you get? Did you press enter several times? I left something off. Oh, I know what I left off. Hang on. I left off one thing. That's my fault. Go back. We got to do, when you're putting this in, I left out one thing. Store that as x, because I didn't store the new value. Okay, go back. Okay, go ahead, store your value. Okay, then we need to do x minus, then we need the parentheses, y sub 1 divided by y sub 2, close the parentheses. Now we need to store that as x. I left that off on my notes.
You need x minus. You want x minus.
Oh, gosh dang it. Yep. Yep. Okay, let's start over again. Negative 0.3, store that as x. We're going to get this right. Okay? And then let's do x minus. Okay? And then do our y sub 1 divided by y sub 2, parentheses, and store that as x. Okay, now there's the first one. It went up, and I got negative 0.32232. Okay, now press enter again. So it's going down the tangent line. Okay, now this time I got negative 0.322185. Okay, press enter again. Okay, and press enter again. You keep pressing enter until all of them are alike, and now they're all alike. Okay, okay, so our final root, okay, is negative 0.3. On this one, you want to write down all the decimals. Okay, so I messed up on this. You have to store this as x. Okay, I left that off the formula. Okay. Okay. Okay, now let's check. Another way, okay, is to use, and see how close we are, use the keyword solve. Remember, every keyword on your calculator is under catalog. Okay, so in catalog is right above the 0. Okay, so do second function catalog, and this lists everything from A through Z. Okay, I don't want to scroll through that much, so do alpha S. So use the green alpha key, and then do S. It's right above the natural log. Did I get down there quicker? Nope. Second function catalog. Do alpha S.
You turn your alpha off.
Oh, I've already had it on.
Yeah.
It's not a good day. There we go. Get down to solve. There we go. And pick up the keyword solve. Okay? So solve y sub 1. We've already got the formula in there, the function, and x, and then my guess, okay, was a negative 0.3. Because if you have more than one place where it crosses, you have to tell it a number close to that, otherwise it doesn't know which one that you want to solve. So use the vars key, y variables, pick up y sub 1, comma is right above the 7 on a key by itself, and then x, comma, and negative 0.3. Okay. Okay. And you should end up with the negative 0.32218535546. Okay. Okay, now this one converges to a point. Newton's method does not always converge to a point, and that's when you end up with some different things like chaos. Okay. For example, if I had a graph that was something like this. Okay, Newton's method does not always converge. To a point. If I had a graph like this, something like that, okay? What happens on some of these is you might say, okay, I'm going to pick a guess. Okay, my guess goes up to the graph. I go down the tangent line. Okay, it picks up a point. It goes down to the graph. The graph would be down here. Okay, it goes to a tangent line, goes back up to the graph, and you're going to get the same. It's not ever going to converge to where that is. Okay. And if you end up with a graph, like this, something like this, where it crosses 3 times, you've got to say, okay, I'm going to do a guess close to this one, okay, to try to find that point. If you're going to try to find this one, it's got to be close to that point, okay. If you're going to try to find this one, you got to pick a point close to that point. Okay, now what I want you to do next